Welcome, class. This is now section 4 of chapter 2 in your book. We are finally getting to the point of postulates. Again, we've already talked about. Really? We've already talked about postulates 1 through 4. The ruler postulate allows me to use a ruler to measure a length. The segment addition postulate, which allows me to add two smaller segments, length to be the larger segment's length. The protractor postulate, which allows me to use a protractor to measure the angle. And then the angle addition postulate, which allows me to add two measures of an angle to be a larger measure of an angle. We're going to be talking about 7 postulates today, postulates 5 through 11. And we're also going to be looking at diagrams and what postulates allow me to make which statement. The first 4 postulates we need to talk about are postulates 5 through 8. None of these have a specific name, like postulates 1 through 4. These you generally won't be using in proofs, but you do need to know them. They're what allow me to draw things or allow me to make some statements. For instance, postulate number 5, through any 2 points there exists exactly one line. That means if I had a point here and a point here, there's only one line that can go through these 2 points. Ever. That's all postulate 5 says. Is that there's only one line, exactly one line that goes through these 2. The opposite is also true. If I had a line, there's at least 2 points on this line. Yeah, there should be an infinite number, but a line contains at least 2 points. That's what postulate 6 says. Postulate 7, we've already talked about the intersection of 2 lines. If 2 lines intersect, they intersect at one point. That's what postulate 7 allows me to say. Postulate 8, if I have 3 non-collinear points, there's exactly one plane. I know I said this before. I kind of introduced postulate 8 last chapter, but if I have 3 non-collinear points, they have to be on the same plane, and there's only one plane that can go through them. If they're all on the same line, there is actually an infinite number, and that's why it has to say 3 non-collinear points. Postulate 9, a plane contains at least 3 points, 3 non-collinear points. It's just the reverse. If through any 3 non-collinear points there's one plane, well, a plane then has to have at least 3 non-collinear points. Again, there should be an infinite number of points on this plane. However, we just say there's at least 3. And 10, if 2 points lie in a plane, then the line containing them lies in a plane. So if I have 2 points, there's always one line I can draw through them. Well, postulate 10 just goes that step further. If 2 points are in one plane, then the line that goes through both of them is also in that same plane. And last but not least, just like we had the intersection of 2 lines, the intersection of 2 planes is going to be a line. If we think about a ceiling and the wall, they intersect at a crease. And this crease, if we allowed the ceiling to go on forever and the wall to go on forever, would become a line. So, now that you know all 11 postulates, I might ask you certain things like, hey, identify this postulate. So, for instance, I have 2 pictures here. State the postulate that's being shown. So if I look at example 1 here, part 1, I see a line. Then I see an arrow that says, so for instance, the first part's the if, a line, then a line with 2 points on it. That sure sounds like there's at least 2 points on a line. So I'm thinking this is postulate 6. 2, I see on the left side here 3 points. In fact, they're non-collinear. I can't draw one line through them. So if 3 points are non-collinear, then, well, I see this parallelogram, which usually is how we represent a plane. So now I see one plane that has all 3 points on them. So if there are 3 non-collinear points, then there is one plane that goes through them. Yep, those are the postulates. That last one ended up being postulate. That last one was postulate 8. You probably will see one for each one of these on your homework. Just basically identify the postulate for me. You need to know which one is represented in each case. Example 2. What if I gave you just some random diagram that we had last chapter and I said, hey, write examples of postulate 5 and 7. Alright, so postulate 5 is through any 2 points there is exactly one line. I have a lot of options here. If I choose points G and F here, I could say there's through points G and F there is one line called line GF. That's postulate 5. I could also say through points C and B here there is exactly one line called line L. That's actually the one I ended up going with, but I could have chosen multiple. Alright, so that's postulate 5. Postulate 7 says the intersection of 2 lines is a point. So I have 4 different lines to choose from. What if I chose line CB and line DF? Well, they both intersect at point B. So I could say line CB and line DF intersect at point B. The one I ended up choosing was line DE here, and line BF intersect at point D. Here's the two. The top one's postulate 5. Through points C and B, there is one line called line L. And then for postulate 7, line DE and line BF intersect at point D. The last type of thing that I might ask you in this section in particular is just to use a diagram to determine which statement is true or false. So I have 6 statements over on the left side here. Line AB lies in plane R. Well, first of all, let's look where line AB is. Alright, it looks like it's on a tan drawing here, and this tan part is where plane R is labeled. This is where plane R is labeled. So I would say that line AB does in fact lie on plane R. True. Line FH lies in plane R. Well, point F is here, point H is here, and if I look real closely, this F is on this dotted line, which means it's not actually on the tan plane. This point here is on the blue plane. So if I said line FH lies in plane S, it's true, because that's the plane it lies in. However, it's saying it lies in plane R. False. 2 is false, 1 is true. 3. Line AC and line FG will intersect. Well, we've already said that line AB is in plane R, and we've already said that line FH is in plane S. The only way they would intersect is if they both go through point G here. And line AB is nowhere near point G, therefore false. Even though it looks like they might cross, they actually will not. Alright, line GH is perpendicular to plane R. You know, that looks like it. This is a rectangular shape for plane R, and this looks like it's going in up and down. In fact, it even looks like it might be perpendicular to line GL here. However, there is no marking there. There is no right angle box. So in this case, I would have to look at it and say, it's not labeled. I'm going to have to say false. Even though it could be true. I don't know, so I can't say it's true, but I will say, I probably should actually not say false here either. However, you cannot conclude that it's true here. An angle LGH, so angle LGH is a right angle. Same thing. If I can't tell it's perpendicular, then I can't tell if it's a right angle. Cannot tell, not enough information, or false would be the 3 choices for you. And last but not least, angle LGH and angle LGF are supplementary. Yeah, you can say that because you know line FH is a line, and you know that these 2 angles form a straight line or form a linear pair. Therefore, they have to be supplementary. Alright, at this point you should be able to identify a few postulates, how to use them, where they show up, identify them in diagrams, so on and so forth. Till next time.